Hi everyone, this is Ms. Koltanova. I'm going to go over volume and surface area that's on the back of your packet, and we're going to just fill out the graphic organizer for volume only, and then we could do a lot of that in class where we just practice. Before we get into that, I want you to take a look at what you're going to get on the EOC. If you notice, there's not really much there. Sine, cosine, tangent, which most of us already know, and then 3 volume formulas. V equals BH, 1/3 BH, 4/3 pi r cubed, and none of those list which of your shapes that volume formula is for. So you have to make sure that you study your volume formulas because that's not really much information. Additionally, where I highlighted that capital B, that's an area formula in and of itself. We're going to talk about what that big B means, but every shape is going to have a different formula that is going to be substituted in for that capital B. So you need to be aware of that. All right, let's take a look at your graphic organizer, and we're going to talk about 5 shapes: prisms, cylinders, cones, pyramids, and spheres. Okay, now the first 2, the prism and the cylinder, they have a lot in common. That's where we're going to start, and then we're going to make our way down. Now, before we get started, so that you understand what volume actually is, volume, that's how much it takes to fill up a shape. So imagine that this prism that we have pictured here, that diagram, let's say it's this huge aquarium at some amusement park or something like that. And you want to figure out how much water it's going to take to fill that up, and water is expensive. So if you're trying to figure out how much water to put inside of this aquarium, you're going to need to figure out volume. Okay. Now, if you take a look at the next shape, and just erase that for a second. If you take a look at the cylinder, maybe for the cylinder, you're trying to design like a Pringles box, and you need to know how much material you need to create to cover the cylinder and make your packaging for your Pringles box. Or Pringles container, whatever it is, then you would need to know surface area, because that's going to tell you how much to cover your shape, to make the shape. So to know how much material to cut out and actually construct your object. Right? But we're going to be working and focusing first on volume, which is to fill something up, to put something inside. Right? So let's go ahead and take a look at our first shape, our prism. And what's special about a prism and a cylinder? They do have something in common. They both have 2 bases, a top and a bottom, for example here. Top and a bottom base that are parallel. So we're going to take a couple of notes about our prism and our cylinder before we start filling in our volume formula. So for our prism, there are 2 bases. And your bases are parallel. So here would be like the bottom that's highlighted in yellow with a capital B, and then the top. So I'm going to go ahead and put that they're parallel. Now for a rectangular prism, it doesn't really matter which ones you call your bases. They're just across each other, opposite from each other, and they are parallel. So it could be the front and the back, or the left and the right in this case. But you can have prisms that have any shape as your base. So you can have a prism that has a triangle or an octagon or a hexagon as a base. So one thing we're also going to write in here that the bases can be any shape. Now, if it was an octagon, you would call it an octagonal prism. So the name of the base shape and then the word prism. So in this case, this would be a rectangular prism. Now, additionally, you'll notice that all of the sides of your prism are going to be rectangles. So this is a rectangle here. That's the right side. The left side is a rectangle. The front is a rectangle. The back is a rectangle. So all of the sides are going to be rectangles. So we're also going to write that in there. Okay, the sides, that's hopefully neater on your paper. The sides are rectangles. All right, now volume formula. The volume formula for any prism, doesn't matter what the shape of the base is. V equals big B H. Now we need to talk about what that big B means. Now if you notice, they put that big B on the bottom of your rectangular prism and they shaded in that bottom. The reason they're doing that is big B stands for area of your base. So in this case, our base is in the shape of a rectangle, so you could substitute in length times width for your big B. If it was any other regular shape, maybe it's, let's say it's a regular pentagon, or in this case, what am I going to end up creating? That's a pentagon, certainly not regular, but let's assume that it is. Then our capital B, if it's a regular pentagon, would be replaced with a formula for a regular pentagon's area, which is 1/2 apothem times perimeter. That's what the big B would be if your base was in the shape of a regular pentagon. So just understand that capital B is a very important concept, and it means area of your base. Okay. Now your height is also a little bit of a tricky concept because height represents the length, the perpendicular length that connects your two bases. So I'm going to write down height for now, but you have to know height is what connects your bases. And I'll give you an example of why that's important when we get to the cylinder. Okay. Now let's take a look at our cylinder. So for our cylinder, again, we have two bases, the top and bottom. They are parallel, so it's kind of like it is a prism, but it is a very special type of prism. It's curved, so we don't really call it a prism. We call it a cylinder. All right, so there's lots of shapes that are in the shape of or lots of real-world objects that are in the shape of a cylinder, and your volume formula should be the very same thing as your formula for a prism because there's two bases. So here's our volume formula for a cylinder. It's capital BH. However, since your cylinder has the top and bottom always being circles, we're going to replace the capital B with what the area formula is for your base, which is a circle. So we're going to write down, instead of the capital B, the big B, we're going to write down the area for a circle, pi r squared, times the height. So that's the official formula for volume of a cylinder. And we know that R is the radius, the H is the height, what's connecting your two bases. Now this is a good example for when I can bring in this concept of height being a little weird. Imagine I have a cylinder that's on its side. So here's my two bases, and my cylinder's connecting them. Imagine that looks nice and neat. Now your height would be what connects your two bases. In this case, your height is not standing straight up. This would be your height. It's connecting the front and the left and the right bases. Imagine that if I were to rotate this shape and have it stand straight up, your height would still be that pink side. It's just now standing straight up like we're used to seeing. So be very careful. Your height is always just what connects, the length connecting your two bases. All right, let's move on to the cone. Now for the cone and for the pyramid, you'll notice that there's something special about it that makes it a very recognizable cone or pyramid, and that's the little point at the top. Now these points are not just called points, they actually are called special name, a fancy name, which we call the apex. So that's the apex, and this one also, it's an apex. Now we have lots of different things listed in this diagram, and we're going to get to them in a second. All right, but before we get started, for a cone and for a pyramid, there is only one base. Okay? One base for a cone, one base for a pyramid. Opposite that base is your point, your apex. So you have to keep that in mind. Now, anytime you see that there is an apex, your volume formula is going to change. It's not just going to be a big BH. Now, you're going to have volume equals 1/3 big BH. And again, 1/3 big BH. However, with a cone, since big B isn't going to change, it's always going to be representing the area of your circular base, we're going to fix this formula. So instead of capital B, we're going to replace it with the area formula for a circle. So it's going to be V equals 1/3 pi r squared h. And pi r squared is that area formula for a circle. And then we're going to take a look at your diagram because this is where it gets a little confusing. Your height is always thinking about your shape as sitting on a table and how tall your shape is. In this case, our height is drawn right here to the center. And that's usually how you're going to see your height. Maybe they're going to show you the height on the outside like this. But your height is how tall your object is. What other measurement they're listing in here is this thing that they're calling the slant height, the slanted length of your cone. That is not going to be used in your formula for volume. We're going to use that in surface area, but not for volume. So you have to be very careful. Okay? Your height, the h, needs to be the one that's on the inside perpendicular to the ground, or on the outside perpendicular to your ground still. Okay? Now, the reason why you have this like little right triangle form is you may be given more advanced problems where they give you the length of the slant, let's say it's a length of 10. They give you this radius, maybe it's a length of, let's say, 8. And you'd have to solve for your height in order to get the volume. This is a situation where you're going to have to use Pythagorean theorem. A squared plus b squared equals c squared. And you're going to use that right triangle on the inside. So this would be a situation for that. If you did plug in your values, you're going to get that the length of this height is actually 6, and then you could use that in your volume formula. Okay? Now, for your pyramid, your base can assume any shape. Your base can be in the shape of an octagon, a hexagon, a pentagon, just like we talked about before. So again, we're going to write into here that your base is any shape. So you're not going to be replacing that big B with pi r squared. You're going to be replacing that big B with whatever area formula you have for your base. Now again, they're showing you a slant height, a regular height, things that are perpendicular. So what again, I want you to make sure that you mark down, this is the height that you use in your volume formula. It's the one on the inside. That's the official height. Okay? Or if they gave it to you on the outside, that's your height. That's how tall your pyramid is. The thing on the outside called the slant, okay? You're going to use that for surface area because it's how tall the side of the pyramid is, but it's not actually how tall the full pyramid is. Now that alludes to something important that you need to notice. For your pyramid, look at the shape that all of your sides are in. All of your sides are in the shape of triangles. So we're going to write that down as well. Okay? So all of your sides are triangles. Okay? All of the sides in the shape of triangles. So when we get to surface area, you're going to need to remember the area formula for a triangle to get the area of this yellow portion I just highlighted. Now, the last thing that you have to know the volume of is a sphere. So, like the Earth or a basketball, something like that would be a sphere. Now, you also have situations where they give you a hemisphere. Just like the northern and southern hemisphere, a hemisphere is half of a sphere. Okay, so imagine doing half of a sphere. So you do half the volume of a sphere to get the hemisphere's volume, or half the surface area of a sphere to get the hemisphere's surface area. Volume formula for a sphere. Volume equals 4/3 pi r cubed. So the only thing you need to get volume for a sphere is just the radius, and then that is it. You just plug it into your formula. Now you get the radius from the circle inside your sphere. That's known as the great circle because it's wonderful. A great circle. And then that would be all that you need to get volume. And that's it. We're done. So make sure you have all of these notes. I'm going to write down R represents radius. And we're going to apply this in class. All right, see you then. Bye-bye.